Hi, everyone. I'm Paula Harvey of Tejon Ranch Conservancy, and today we are going to start our unit on inquiry and investigation. To me, this is the core of why we do nature journaling. This is scientific and it is important. So we're going to have a lot of fun with all kinds of new ideas that you may never have heard of about why we ask these questions that we're going to learn to ask and what kinds of answers we're looking for. Let's get started. So today we're starting on the unit called Inquiry, Investigation, and Scientific Thinking. And in it, we're going to talk about intentional curiosity, meaning we're not just going to be naturally curious, which we all are, but we are going to be curious with a purpose. And we're going to be learning how to ask questions and how to pursue those questions to come up with some answers. And in doing this, we're going to learn how to have fun with questions and curiosity. And we're going to learn what it is that scientists already know, that learning these new mysteries and exploring them and investigating them is really, really fun. So, getting started, you can train yourself to be more curious and to find those mysteries everywhere you look. I have a friend, his name is Rod, and he's brilliant. And you know how I know he's brilliant? Not because of what he knows, but because he is constantly asking questions. And he said that when he was a kid, he'd be asking questions until his dad would get angry with him and say, "Stop asking questions." And the reality is that oftentimes we all think we need to know the answers to things, when in fact, all we need to do is know the questions about things. Finding the answers is the fun in life. Knowing the answers is not the ultimate goal. And so if you're one of those people who ask questions all the time, if you're one of those people that annoys other people because you've got all these questions, congratulations, you're hecka smart. And that's why you ask those questions. And don't stop asking. If someone wants you to stop asking questions, they want you to lose your curiosity. You don't want to lose your curiosity. This world is amazing. It's mysterious. There's wonders all over the place, and you don't want to miss those. You want to see each and every one of them. So, why should you develop that sense of curiosity that I'm talking about? Like, here are the reasons. Curiosity helps you to focus your attention. If you have trouble paying attention, it's because you're not feeling that sense of wonder. Curiosity helps you develop that, and it helps you to focus. It drives discovery and investigation. That's why all the amazing things that have been discovered in this world have happened. It's because of people who have great senses of curiosity, and they didn't let things go. They kept investigating. It increases your intelligence. It improves your memory and your thinking. And it promotes this flow state in your mind that helps you perform your very best work. And you know that everybody wants you to do your very best work. So if something happens where you say, that's odd, that's a moment where you can develop your curiosity. And I'm going to give you a toolkit of ways to be curious. So the first thing you want to do when that happens, where you see something where you went, that's interesting, or that's odd, don't ignore that. Stop ignoring those moments. Pay attention to them. Do something about it. Say or write a question when something odd happens. Really purposely stop what you're doing and pay attention to that oddity. Ask a question. If you don't have a piece of paper, just get in the habit. Ask the question out loud. If anybody's around, they'll hear you ask. If no one's around, doesn't matter. Ask the question. The next thing you need to know about curiosity is it makes you slow down and pay attention. Those mysteries are all around us, all around us. And if you slow down and pay attention, you're going to see them. And then it's your job to try and unravel those mysteries and figure them out. And that is where it's fun. Remember, the purpose isn't necessarily to find the answer, it's to find the question. So, we talked about open inquiry. What is that? Open inquiry is shifting back and forth between three things. First, observation. You look at something, you say, that's strange. And then you ask some questions. So the next thing you've done is you've observed, asked some questions, and then come up with some possible explanations. Just can be anything you're thinking of. Remember, not the right answer, just as many possibilities as possible. It's what scientists do all the time. How do you think great discoveries happen? Because a scientist looked at something and said, that's odd. I wonder why that happened. And then they said, maybe it was this or that, or maybe it could be this. And then they started working with those possibilities. And that's what you're going to do. Remember, and I'm going to put this right here, the goal is not finding the right answer. The goal is finding the question and the possibilities. And sometimes you need to accept this. You may never find the answer to that question, but while you're learning, while you're looking and observing and questioning and coming up with those explanations, you're going to learn a lot through that process. So, what's the purpose of open inquiry? This is the thing that you don't necessarily get taught at home or in school. We are allowed to explore, to notice, to wonder, to propose explanations. We are allowed to make mistakes. It's really important. If you want to learn, then you need to make mistakes, because if you always get the right answer, you're not really learning. If you're making mistakes while you're pursuing those answers, then you're learning. And another thing, you are allowed to change your mind. So if you've got a hypothesis about why something is happening, and after you've observed it and you've tested it, and it doesn't seem to be the right answer, change your mind. That's what scientists do all the time. And that is the purpose of open inquiry. So, what are the best practices for making a good investigator? Here they are. One, always include that metadata that you've been doing every single time you've done a journal entry. What is it? The date, the time, the location, the weather, other important things that may be happening around you that you want people to know and you want to be able to remember. That's the metadata. Next, make those observations. It's the same stuff. I notice, I wonder, this reminds me of. Do that typical journal entry. That's the very basic thing that you do when you're journaling. And then intentionally, purposefully ask those questions and include those questions from observation and from curiosity scaffolds. And I want you to remember what a scaffold is. If you look at a scaffold that's on a building that's being built, it's what holds up that building, and it holds you up as you're building that building. It's those things that support. And that is what we're going to go over today. That's what that curiosity toolkit is all about, is those curiosity scaffolds. So for example, one of those curiosity scaffolds is asking the 5 questions: who, what, where, when, why, and how. 1, 2, 3, 4, 5, and that's 6 questions. Who, what, where, when, why, and how. The next thing is to pursue those questions that you can answer in the moment through observation. So if you've asked those questions, now look and see if you can answer those questions just by what you see. Now, when you do this, there may be some little fun tools that you can do, like a Y web, or a question chain, and I'm going to show you those a little later. But the whole idea is to try and answer those questions with possible answers. Now remember, if you've got only one answer, but you've come up with 5 or 6 possibilities, not all of them are going to be correct. That's fine. So in continuing with those best practices, don't forget to distinguish between what you observe and what the explanation or explanations might be. So you might want to add to your journal some icons or symbols for each of those pieces of information. If it's a question, it might be a big question mark at the beginning of that question to make sure that you know when you're looking at your journal, this is a question. And then it may be something else like an exclamation mark or some other kind of symbol that you want to put in there. That's just fine. Any of those things work. So add that to your journal. So it's really easy for your eye to catch what are the questions and what are the possibilities. Always, always, always support your claims and your generalizations with evidence. This is science. So you can always say, could it be, or maybe it is. But once you've decided this is probably the answer, you need to have evidence of why you think that is the answer. You can always change your mind if that evidence suggests otherwise. That's fine. Change the way you think. That's the purpose of this, not to come up with the right answer. Remember, that's not the goal. If you're going to look things up, make sure that you cite those sources into your journal, and make sure before you cite those sources that you have vetted those sources. Are those sources good places? Does the website have an edu or an org? Is the person who's writing about that an expert in that field? Or is it just some strange little place that you found on the internet? Just because it's in the internet does not make it true. In fact, more times than not, what's on the internet is not true. So you need to be sure that if you're looking things up, you know that the information you're getting is good information. And then the other thing to keep in mind is that we all have our biases. And that means we might be leaning in one direction or another. We might want to prove something. And in doing that, we may be ignoring the facts. So be careful that when you're collecting information out there, when you're looking and studying things, and you're trying to figure out whether or not this thing repeats itself, consider your own personal bias when you describe or diagram a method, or when you test something. Make sure that you're doing this in a random way and not just in one spot or with one thing, but that you're doing it in enough ways to prove what you think is probably true. Now, I'm going to give you these following slides of 5 different tools that will help to develop your curiosity. Some of it is a little complicated and some of it is super simple. Each approach can be used with the other approaches. A little of this, a little of that, any of that can be used. So I want you to look at it and see what is it you like that's in this. And start with those things that you like to begin with. And then as you get really good at this, and better at asking questions and more curious, you can then expand and use those other approaches as well. So the first part of your curiosity toolkit are those curiosity scaffolds, the things that hold you up and support you, and question generators. So, oh gosh, I see something, but I don't know what to ask. So here's what you do. So just a reminder, a curiosity scaffold is a prompt that helps you to generate rich and varied questions about your observations. Varied questions, extremely important. These are open-ended observation-based questions. So it's not a yes, no, that's not open-ended, that's closed, but something open-ended where you ask a question and the answer becomes long and perhaps quite detailed. And it allows you to investigate further. So basic ones, I notice which are the observations. I wonder which are the questions. And remember the 6 questions: who, what, where, when, why, and how. This reminds me of, those are those personal connections that you make with something previous that you have experienced. Oftentimes we see something that reminds us of something else because there's a relationship there. And that's very, very important. And then after the I wonder is that could it be? Those are those possible possible explanations that are worth exploring to find an explanation that may or may not be correct. So the second part of that curiosity toolkit are a few of these other things. So before you even begin to journal, you want to prime your curiosity by writing down the words patterns and change on your page. Write them big and bold where you can see them so that it reminds you to constantly look for patterns and for change. Those are basic fundamental things. And we've gone over both patterns and change, among other things. And we're going to go through that once again. If there's anything else besides patterns and change that you want to remember to do when you are doing an investigation, write those things down too. Write them big and bold and block them in and make them colorful so that it reminds you constantly, this is something I need to keep in mind. That's intentional. All right. So that's it. That's number 2. But number 3 is those NGSS, the next generation science standards that you have been working with throughout our journaling process, and that are used in schools to teach science. These are those big ideas that scientists use all the time. And here they are. There's 7 of them. Patterns, cause and effect. You remember this? Scale, proportion, and quantity. Stability and change. Remember, we did that string project. The string project was stability and change. Structure and function. Systems and system models, and energy and matter. So that's number 3. Number 4 are those 5 W's and an H: who, what, where, when, and how. Now, these are the simplest of questions. This is the baseline or the beginning to start getting in the habit of asking questions. All right, let's talk a little more about those cross-cutting concepts. So this stuff might be a little dry to you right now, but just listen, because this is the stuff that we are really working with. So what are patterns? Ask, what patterns do you notice? How can you describe that pattern? Are there exceptions to the pattern, and what might be causing that pattern? And what does a pattern remind you of? Now listen, I'm giving you those questions that you can answer, that you can investigate. Cause and effect. Here are the questions you want to ask. What happened here? Why is it like this? What might be causing the effect you observe? What are other possible explanations? What might happen if, and is this causation, did something cause something else, or correlation? It's kind of related to each other. Maybe it's coincidence, and maybe there's a reason they're related to each other. And how do you know? Take a look at this. Lots of whats and lots of whys. Scale, proportion, and quantity. Here are the questions. At what scale have you explored this phenomenon? Is it just a really small thing? Remember, we were talking about that anthill way in the beginning? We're about looking at anthills all over in one particular area, or anthills all over one range of areas. For example, anthills in the mountains, or anthills in a valley, or anthills by water. What is that scale? How big are you looking at something? Is it very small, or is it larger? Obviously, the larger it is when you're looking at scale, the more accurate your conclusions will be. Would you think about it differently if you zoomed in or zoomed out? That was like our second lesson, was zoom in, zoom out. That's always important. Can you make a model that helps you understand nature at the scale? And how can you measure change at different scales? What can you quantify or measure at this scale? And how can you measure it accurately? Structure and function. You can ask, what is this like? How might this structure work to help the organism survive in its environment? How does it work? How does is the structure like others that you have seen? That's that connection this reminds me of. How is it different than others that you have seen? How might those differences impact the function of that structure? We went into this a lot when we were doing field guides. Systems and system models. Here are your questions. What are the boundaries of this system? How does that system work? What are the parts of that system? How do the parts interact with one another? How is the system affected by other things? What would happen if something were removed from that system? And what would happen if something were added? Is there a feedback? And what was it before it is now? And what will happen next? And how can you model this system? And the last two, energy and matter. Where does the matter in this system come from? How does it change within a system? Where does it go? How do matter and energy interact in this system? Where does the energy in this system come from? And what does the energy do in this system? And stability and change. What causes change in this system? What is stable in this system? What isn't? What changes quickly in this system? And what would happen if something were different? So the next thing in your curiosity toolkit are those 5 W's and the H. Who, what, where, when, why, and how. Let's just talk a little bit about what kind of questions you can ask. So who, identification and classification. Ask who is it? Who was it? Who will it be? Who made these tracks? Who could have made these holes in this leaf? What bird is that? That's the who. What questions? Questions about phenomenon. Focus on the cause and the effect with what. What's happening? What happened? What'll happen next? What does it do? What will the caterpillars do when the leaves fall from the trees? That's a prediction. What causes the darkened sky above the rainbow? Where? That's space, location, and biogeography. Ask, where is it? Where was it? Where will it be? Where is that bird's nest? Where is the current fastest? And where do frogs go at night? When? That's timing. How long? Ask, when did it happen? When will it happen? What is the timeline? When did this tree start to grow? How? That's a mechanism. How does it work? Focus on form and function. Form and function is part of those next generation cross-cutting concepts. Ask, how do cracks in mud form? How do beavers survive under a frozen pond? How did that tree grow from such tiny crack in the rock? How? And the last one, why? Meaning cause and effect, structure and function. Meaning, cause and effect, structure and function. Notice, you guys, this is overlapping on those cross-cutting concepts. Ask, why did this happen? Why is it this way? Why do small birds fly in a tight flock and not in a V? Why are the leaves of darker green on one side and pale on the other? Why is this plant hairy? Now, the next one are the 8 international baccalaureate key concepts. These are very, very similar to the NGSS cross-cutting concepts with a slightly different and interesting focus. So form, understanding that everything has a form with recognizable features that can be observed, identified, described, and categorized. Ask, what is it like? Function, that understanding that everything has a purpose, a role, or a way of behaving that can be investigated. And this question would be, how does it work? Causation, the understanding that things don't just happen, that there is a causal relationship at work. Remember, cause and effect, we've gone over this. And that actions have consequences, and ask, why is it like this? Change, the understanding that change is the process of movement from one state to another, and it is universal and inevitable. It will always be this way. And you want to ask, how is it changing and how is it stable? What was it like before and what will it become? And what is the rate of change? Perspective, the understanding that knowledge is moderated by perspectives. Different perspectives lead us to put our attention in different places and make different observations. Perspectives affect our interpretation, understanding, and findings. It's extremely important because this is where we talk about bias. Are we trying to lead ourselves to an answer, or are we staying open to the evidence? So you ask, what are the points of view? What is another perspective on this? Reflection, the understanding that there are different ways of knowing. There are different ways of knowing, and that it's important to reflect on our conclusions, to consider our methods of reasoning and the quality and reliability of that evidence. You want to ask, how do I know? How strong is that evidence? How reliable is the source of my information? And the last two, the connection. Understanding we live in a world of interacting systems in which the actions by one individual will affect another. So you ask, how is it connected to other things? How is it part of a system or systems? Remember, system or system models? Notice these are so similar and so overlapping to the NGSS cross-cutting standards. And the last one is not in NGSS, and I love this one. Understanding that people make choices based on their understandings and the actions they take as a result do make a difference. So what is my responsibility and what is my impact in this situation? Sort of that idea that we don't want to affect our environment. We want to live within it and we want to cooperate with it. So let's talk about answers. Now, how do you know? How do you answer your question? So we do a lot more with questions than just look up those answers. So hopefully, you know, with all the stuff we've talked about so far, we've really been focusing on the quality of your question, not the answers. Again, I'm going to keep saying it. This isn't about finding the answers. This is about asking the questions. Learning to engage with nature's mysteries can lead to huge, huge learning opportunities. Science is a system of creating and evaluating testable explanations of natural phenomena. I'm going to talk to you about this. It has to be testable. If you've got a hypothesis for how something works or why something is, can you test it and it'll come out the same every single time? If so, that's science. It's limited to the study of what can be directly observed or inferred, meaning you can come up with conclusions from those observations. Scientific explanations must be testable or able to be supported or contradicted by concrete evidence. In order for it to be science, you have to be able to test it, and the outcome has to either be what you thought it was going to be or different from what you thought it was going to be for it to be science. A scientist should be able to ask, how would you know if I were wrong? Not if I were right, but if I were wrong. How will I know when I'm wrong? A scientific mindset is what we're working at trying to gain here. Ask questions, find mysteries, look for clues, make explanations. Could it be? Try to prove yourself wrong, and then change your mind in the presence of evidence. So you're trying to prove yourself wrong, and you're trying to be ready to change your mind. If what you see is different than what you think, you better trust what you're seeing. And here I've highlighted it. If there is no way to test whether an explanation is wrong, it is not open to science. It must be able to be observed and measured. You cannot put some things into the realm of science if you cannot measure it and you cannot observe it. Our tendency is to rush for answers, and it's tempting to do this with a click of the button, but I don't want you to do that. We can train ourselves to sit with those mysteries, to observe, and to use methods to approach deeper understanding. It takes a lot of patience to do this, but ultimately it enhances our understanding of the world and our connection to it. So don't ask a question and quickly go to the internet to look for answers. Ask the question and then sit and watch and think about what you're seeing and take notes and follow it until it becomes very clear what those possible answers could be. Here are some approaches to exploring those mysteries. The first one's called Let's Go See. Sometimes we can observe an answer to one of our questions right away, if it's possible to answer that question through observation. But it will require additional equipment or time. Then we switch from let's go see to wait and see. For example, if we're growing plants and we want to know what kind of plant this is, I found this seed, I'm going to plant it. I don't know what it is yet. So we have to wait and see by planting it and see what grows. So we'll gather that data and answer that question later. So let's go see might give you an answer, but it might lead you to wait and see. The next one is called Could It Be? Maybe. If we can't directly observe an answer to one of those questions that we come up with, we can come up with lots of different explanations. We can create why webs, which propose several possible explanations to the nature, mystery, or why question. We can weigh one explanation against another using evidence to infer which ones are plausible and which ones are more likely to be right. So you write a bunch of different reasons why it could be, then you sit there and you observe and you go, oh, well, clearly it's not this explanation. I'm going to cross that one right out. So you can eliminate a lot of those could it be's just by observing. Next one, look it up. If we can't answer that question through our own observations, look it up. And see if there's additional information that'll help deepen our understanding. And here's the but about this, but play with your mysteries first. Instead of just turning straight to a source, take a look, observe, think about it, write down those possible explanations. And then don't forget, just because it's written or it's on the internet, it doesn't make it true. You've got to use your brain to evaluate whether or not the source you're using is a good source. And then the last one is let it be. Science is a system of creating testable explanations. Keep saying it because it's really important, of natural phenomenon. If it can't be directly observed or inferred from observations, your question is not a science question, and therefore it can't be answered, and so you should let it be. It's not part of what we are studying, and that doesn't make it important. It just means it's not science, and that's what we're working on today. So here are some approaches to exploring those mysteries. There's a tool for each mystery. For any mystery, we can ask questions, make observations, construct explanations, and look things up. That's what we've just gone over. We don't need to do anything in any specific order. So you can observe something, you can then construct an explanation, you can then make a question, you can do it in any order that works. We might ask that question, come up with an explanation, and then make an observation that contradicts or explains the question. And that leads us to another question. And that's good thinking, when one question leads to another question, which leads to a better question. And that's something we're going to be studying. We might consult a resource to find some piece of information, but then we need to go back outside and validate that that piece of information is actually correct. So the two things that we're going to be working on are called curiosity chains and why webs. And the most interesting questions are rarely those first ones that we ask. We start with a question, but then we have to think, well, what led me to that question? And where does that question lead me next? Being deliberately curious and following a train of thought on a page can lead to learning and wonder and insight, knowledge. So look for what's out there in nature waiting for you. And once you find a mystery, start asking those basic questions that lead to more and more complicated questions. You'll notice that when we talked about that international baccalaureate, A lot of those were who, what, where, when, why questions, but they were written in a much deeper way. And that's those more complex questions. If you can't think up interesting questions from the start with who, what, where, when, why, and how. And that just is a way to start. That's that scaffold that holds you up, that starts you in the process of being curious about something. So a set of observations and questions begins with that unexpected observation. You've been looking around and suddenly something catches your eye. It was unexpected. You're going to start observing that. This stimulates those questions, and that will lead to more observations, which lead to more questions. That's going to be that curiosity chain. Wait till you do one. They're so much fun. If you find yourself saying, that's interesting, you have found an unexpected observation. Use drawings, words, and numbers, just like we've been doing all from the beginning. Use arrows to track the flow of those observations and ideas. So here is a curiosity chain. I love them. They're so much fun. Notice this particular one is about a rattlesnake. They started with a couple of pictures of the general area. They've got some close-ups where they've put circles around them. Remember zoom in, zoom out? They use zoom in and zoom out all the time. And it's one question after another. They use arrows to focus on where they're going. And each arrow leads to the next question. So show your observations and your thinking. Here's a set of comic panels to describe the interactions between these blue jays and a snake. Then there are inset drawings. This is a really good one of the details of the head of this snake. And then words and arrows that track the flow of your observations and your ideas, including different ways of showing those observations and thinking that lead to a really fun journal entry. And notice this particular journal entry is 2 full pages. Looks to me like this person could have gone on to 3 or 4 pages. You're welcome to do that. Looks like fun, doesn't it? Here's another one. So in this one, they're looking at tomato worms. So what is the question behind the question? They start with a question here and they go on with the next question. Wait a minute, why did I even think of this question? Well, before I even answer that question, don't I really want to know what this one is? And then once I've answered this question, what's the next question that comes to mind? Till you become a real expert on tomato worms. The icons like exclamation marks, here's one right here. They have us wait. They have us look. They tell us what's important, what's something to pay attention to. And then there are Y-webs. Now, Y-webs are much faster and easier to do because they don't go into so much detail. Well, you lose something when you don't go into a lot of detail, but it's a really great way to get started. Now, it's always a why question when you're doing a Y-web. So in this particular case, the person writes this question: why does poison ivy have itch oil? Now, all of these arrows are going to the possible reasons. In this case, this person did 5 possible reasons. The last one is something else. They were leaving open that maybe the ideas that they have so far are not complete and they need to come up with some more reasons. Or maybe there's more than one reason why poison ivy has itch oil. So this is a Y-web. Fast, easy to do. Finally, I've been talking and talking and talking because I really want you to understand that we are really doing intentional curiosity here. So we're going to do 2 activities. Now that you have your curiosity toolkit of all 5 tools, we're now going to practice. You'll be looking at 4 different mysteries that you can study. Have fun with this. So the first activity is you're going to go out and find 3 unexpected observations. Remember, if you find yourself saying, that's interesting, you have found an unexpected observation. Create a Y-web for each of those 3 unexpected observations, and then start your journal entry as always, with your metadata. So before you even do a Y-web, hit that journal with your metadata. Write a Y in the middle, and then write several, at least 4 or 5, can be more, possible explanations. Obviously, if there's a reason and you've got 5 or 6 different reasons, not all those reasons are correct. But remember what I said, the reasons, the idea of the possible explanations is what you're looking for, not the answer. In this, I want you to include one sketch and one or diagram with each of your webs. So even though this one doesn't have any pictures, I want you to add a sketch. You can do ABC 1, 2, 3 and that explanation as well. This reminds me of. All of that works very well with Y-webs. Okay, and then the second thing I want you to do, one more thing. You're going to find one more unexpected observation and create a curiosity chain for that observation. But don't do this one until you've done the Y-webs. The Y-webs are going to be your warm-up, because a curiosity chain is going to be asking you, or going to be expecting from you, that you're going to start asking a question that leads to a better question, that leads to another question that's more complicated. And remember, you can use those cross-cutting standards, the who, what, where, when, and why, the I notice, I wonder, this reminds me of the International Bachelorette, all of those things you can use when you're trying to develop these questions. So if you get stuck, go back into this PowerPoint and look for those examples of questions that I included in there. That's part of this toolkit of yours. And in fact, if you want, you can do a whole page on the different ways to ask questions and keep that in your journal so that you can keep going back to it to help you with your high quality, intense questions. Okay, so remember to include icons like exclamation points and question marks. Highlight those key discoveries. Write your first question and then let that question lead you to the next question. This is the fun part. When a question goes to a question that leads to another question, then you're really, really thinking. You're really being curious. And use the language of uncertainty. Do you love it? I'm not telling you to find the answers. I'm telling you, you're not sure. And the idea here is you don't need to be sure. So the language of uncertainty is saying things like, well, maybe it's this, perhaps it's that, or could it be this? It's not the answers. And then remember, use those ABCs, those 1, 2, 3s, and those drawings and sketches to make something that looks really cool. Don't forget those arrows. They help a lot. Once you are done with this whole project of 3 Y-webs and 1 curiosity chain, I want you to write a short summary, just like we've been practicing. It starts with a topic sentence and it ends with an ending or closing sentence. And I want you to explain what you learned while you were increasing your curiosity by asking questions. Now, what I want you to focus on is what's going on inside you, not what you learned about the things you were studying. What did you learn about your own curiosity? Were you able to increase it? Did you find it exciting and fun? Was it difficult to ask those questions? And here's some questions that you can think about while you're trying to come up with a way to write this paragraph. What was it like to observe, explore nature's mysteries, and come up with explanations? So we're not talking about the specific thing you were doing, but the process. What helped you to learn during this activity? Not what did you learn, but what helped you to learn? What questions did you ask? And what skills do you feel like you got better at by doing it? Did you get more curious? Were you better at asking higher level questions? Those are the things that I want you to think about when you're reflecting. This one is not just a summary of what you did, but a reflection on how this changed you and affected you. And that's it for now. I wanted to show you a beautiful, magnificent, very old, probably 300-400-year-old valley oak that's found on Tejon Ranch Conservancy. It's a beautiful old tree. And maybe you'll be able to come out one day and do some journaling under it. That's all for now. We'll see you with the next inquiry lesson.